Okay, we're going to look at graphing the inverse of a function, but we have to first understand the relationship between a function and its inverse, because what we're going to be doing is we're going to graph the inverse function, graphing the inverse function using the original function graph. Okay, so we're going to take the original graph of a function, and then we'll use that graph to determine the graph of the inverse function. So in general, the relationship between a function and its inverse, say f and f inverse, the domain of one equals the range of the other and vice versa. Well, the elements of the domain are the inputs and the elements of the range are the outputs, so that means the input of one equals the output of the other and vice versa. And finally, inputs are x values and outputs are y values, so the x values of one are the y values of the other and vice versa. So this third statement is really important, but all three of these mean exactly the same thing. It's just different ways of saying the same thing. So we'll use this to graph a function. One other thing I want to remind you of is that inverse functions are only functions if the original function is one-to-one or injective, and a function is one-to-one or injective if it passes the horizontal line test. So the functions we're going to be doing this for must pass the horizontal line test so that the inverse is actually a function. So here's an example of a function f that is injective because it passes the horizontal line test. It only hits at one point if you draw the horizontal line anywhere. It's injective, so we can consider its inverse. And to graph the inverse, what we need to do is remember that all the x's over here are y values over here, and all the y values here are x values here. So, you know, a good idea maybe would be to set up a table of x and y values from this graph. So I've got a point here. Let's choose some nice points. How about this one? And how about this one? So this first point is the ordered pair 0, 4. The second point is the ordered pair 1, 5. And the third one is the ordered pair 2, 1, 2, 3, 4, 5, 6, 7, 8. And that may be enough. So whenever we look at those same order pairs over here on the inverse graph, we simply switch all the x's and y's. So 0, 4 becomes 4, 0, 1, 5 becomes 5, 1, and 2, 8 becomes 8, 2. So let's plot those points. 4, 0 now is on the x-axis, not the y-axis. 5, 1 is right here, and 2, 8 is right here. Okay? So maybe that's enough to see what the graph is going to look like, but maybe it's not. So another thing is graphs of inverses are symmetric about the line y equals x. So let me graph that line. If you're not familiar, it goes to the origin, it has a y-intercept of 0 and a slope of 1. So if I were to graph that line, it would look something like this. And the two graphs should be mirror images of each other across that line. So let me pick up the graph of f here real quick, and I'll make sure to keep it in black, and I'll put it on the same spot on this graph. And now, using the fact that the blue graph has to be symmetric, a mirror image across the red line, along with the points we have, we can see that the graph should look something like this. And I hope you can see that they're mirror images of each other. So the graph of f inverse is this blue graph right here. Swap the order pairs and then use the symmetry about this line, this diagonal line to the origin, to figure out what the graph looks like.